In video lesson number 2, we will continue to talk about proportional relationships. Specifically, we're going to look at when proportional relationships are represented as tables and graphs. You'll recall from the first video that a proportional relationship is a relationship between two variables where the quantities stay in the same relative size to each other. Or in other words, the two quantities will always be in the same ratio to each other. In video number 1, we looked at written descriptions and some examples of proportional relationships when they were represented as a written description. We looked at the example of an athlete who runs 1 mile every 5 minutes, and also the example of a farmer who sells apples for $3 per dozen. We will continue to look at those two examples in the context of tables and graphs. In math, tables provide information about the relationship between two variables by organizing multiple data points into two columns. Here we see an example of tables that were created for those two written descriptions we discussed earlier. An athlete who runs 1 mile every 5 minutes, and a farmer who sells apples for $3 every dozen. If the athlete were to run for 10 minutes at that rate, she would cover 2 miles. For 20 minutes, they would cover 4 miles. And by 40 minutes, at 1 mile every 5 minutes, they would have covered 8 miles. Our question is, how can we recognize that the relationship shown in each of these tables is proportional? Pause the video and try to figure out what could you do to prove both of these tables have proportional relationships. Welcome back. The key is to look at the ratios created in the two tables. For any data point you pick in the table, the ratio of y over x should always remain constant if we have a proportional relationship. 2 miles over 10 minutes, 4 miles over 20 minutes, or 8 miles over 40 minutes, those are all ratios that could be simplified down to the rate of 1 mile every 5 minutes. Similarly, $6 for 24 apples or $9 for 36 apples would always work out to be 25 cents for every 1 apple. Because the ratio remains constant for any row we select, we know that these relationships are proportional. We also want to know what would happen if we took these two proportional relationships and we graphed them. As you should recall from an earlier video, when we talk about graphs, we mean we're using the coordinate plane to create a visual representation of the relationship between two variables. That coordinate plane allows us to plot multiple data points from the relationship onto a graph, and that graph can then help us see the rate of change and project other data points in the relationship. We see here the two examples from above, the athlete's run and the farmer's apple sales, have been plotted onto a coordinate plane. The first blue dot here shows us that after 10 minutes the athlete had run 2 miles. The second blue dot shows us that after 20 minutes the athlete had run 4 miles, and the other data points for both tables have been graphed onto coordinate planes as well. Our question is, how can we recognize that the relationship shown on each of these graphs is proportional? Take 30 seconds and pause the video to think about how you could prove these two relationships shown on the graphs are proportional. Welcome back. There are two key things that we're going to notice about every graph for a proportional relationship. Number 1, the data points are going to form a straight line, and number 2, that straight line is going to pass through the origin. We see here those two graphs. We've now plotted a straight line, and it goes right through all 3 data points and starts right at the origin. We see the same thing for the farmer's apple sales. At 0 apples, they have $0 of revenue, and then a straight line hits each data point.